Welcome to the Analytic Christian. I'm Jordan, and this is the channel that helps you explore Christian philosophy and theology. I am joined today by Dr. Matthew Flummer, a professor of philosophy at Porterville College, and he is the co-host of this excellent podcast called The Free Will Show with my friend Taylor Sear. So thank you so much for coming on, Dr. Flummer.
You're welcome. Thanks for having me.
I would highly encourage you all to go check out The Free Will Show after you finish this video. And this video is an Ask a Scholar video, meaning one of my patrons submitted a question, and this is the question: does neuroscience disprove free will? So, what do you think?
The short answer is no. But I guess the question you might have is, why would anybody think that neuroscience disproves free will in the first place? And you can summarize the basic idea like this. There's something happening in the brain that neuroscientists have discovered, and it seems to happen before a person is consciously aware of what they're about to do. So it seems like that shows that conscious awareness is not playing a role in the action that's produced or that you perform. And if the act is produced unconsciously, then it seems like conscious free will is not producing the action. So that's the overall picture of like why somebody might be worried about what neuroscience has happened or what neuroscience says about free will. So we can get a little bit more into the detail and ask, well, why would people think that there's some kind of mental activity happening before people are consciously aware of decisions that they make? And neuroscientists have performed three basic kinds of experiments. There are EEG, which measures electrical activity in the brain, fMRI machines that, if I understand them correctly, they measure blood flow. So it measures electrical activity indirectly by measuring blood flow. There's a kind called depth electrode, where people actually have the top part of their skulls removed for other kinds of processes. So like if they have severe epilepsy, sometimes they'll go through a procedure where the top half of your skull is removed. And neuroscientists get permission to come in and do experiments because the people are in the hospital for a long time and they're bored and they're like, oh yeah, I'll participate in this experiment. And there's actually electrodes placed into the brain itself. That's why it's called depth electrode.
That's
In
intense.
each of these all three kinds of experiments, participants are asked to perform simple bodily movements or bodily actions, like flexing your wrist or pressing a button with a single finger, or maybe an arm movement. For instance, in one experiment, in one of these button press experiments, scientists were able to predict with 60% accuracy about 8 to 10 seconds before the subject was consciously aware of the decision to press the button. So 8 to 10 seconds is a long time in neural activity, but it's only 60% accuracy. That's barely more than a coin flip. In another experiment, experimenters got the accuracy a little bit higher, so they had about 80% accuracy of what people would do before they did it. Not quite as far in advance. So that's the basic structure of these kinds of experiments. And I think the best way to explain in a little bit more detail about what happens in these experiments is to explain the most famous one called the Libet experiment. So I've got a slide here that shows you what's going on in the Libet experiment. It was back in the 80s, so about almost 50 years now when Libet did this experiment. And you can see the device that's placed on the person's scalp. So this is the way EEG work, with all the wires connected to the different regions of the scalp, and it's able to measure electrical activity, like I said before. So there are two different machines that the person is hooked up to in this experiment. The first is the scalp device, and there's another machine that's hooked up to their arm that measures the muscles firing in the arm, because they're asked to flex the wrist. They're also asked to look at this clock-like thing. So it's you can see the dot at the top. That dot moves around very quickly. I think it's supposed to go around a complete revolution around the circle in 2.5 seconds. So it moves pretty quickly. And the people are instructed, when they get everything hooked up, to flex their wrist whenever they felt the urge or decision or wish to do so. After they flexed, they would report this where the spot on the clock is. So they're watching the clock, the dot move around the clock. They wait until I'll move now. And then they report where that location on the clock was when they first felt the urge or decision or intention to flex. So that's the basic setup of the experiment. Okay. And this is what Libet found. So we're looking here at the results of the EEG. So this line that kind of slopes upward is the brain activity. And you see that it's labeled here with a couple of different things. The first one is rise of RP at negative 550 milliseconds. The second one to the right is the W. Sometimes it's called W time. It's the awareness of the intention, and it's about negative 200 milliseconds. And then the action is at 0 milliseconds. So you can see clearly there's something going on in the brain before the person reports a conscious awareness to move their wrist. The RP, like I said, is called readiness potential by Libet. So it's about a half a second. I think he calls W because it's a conscious willing. So maybe it's for willing. I'm not exactly sure. And it's 200 milliseconds. So there's 350 milliseconds, about 0.3 of a second before the person is consciously aware that the rise in the RP happens. So this is what was supposed to worry us, that our brain is doing something before we're consciously aware of what's happening. So we could then think about, well, what would the argument look like? So we've got data from the neuroscientific experiment. And in order to prove that there's no free will, we need to put that data into an argument. And I've constructed what I think is a pretty straightforward argument that concludes that nobody's free because of this kind of neuroscientific evidence. So we can talk through the argument, and I'll give you kind of an overview of what the defense of each premise would be and kind of the logical structure. And then we can talk about why, or the different reasons for why this argument fails.
Okay, so, sounds good.
Yeah. Premise one, if the brain caused your decision before you're aware of that decision, then the decision isn't free. Premise two, the brain causes your decision before you're aware of it. Then we have a sub-conclusion there. Therefore, your decision isn't free. And then another step in the argument, all decisions that you make are just like that one, that decision. Therefore, or so, none of your decisions are free. So premise one is this idea that free will necessarily involves consciousness. And the idea is that only conscious decisions are free ones. Free will necessarily involves deliberating, and deliberating involves weighing reasons and thinking about pros and cons, and all of that happens consciously. So on the face of it, this seems like a pretty plausible premise. Premise two is what the data from all the neuroscientific studies gives us, that our brain is doing something and they are interpreting it as it's causing our decision before we were aware of it. Premise three, this is set up from modus ponens. So I wanted to make sure it was valid. So 1, 2, and 3 are valid. So the only way to reject this subconclusion here is to reject one of the premises. Now, the first step from modus ponens is deductive, and then we move from a deductive step to an inductive step. So this is kind of like a generalization, which is a kind of inductive argument where we're saying, well, that decision's not free. All the other decisions you make are just like that one. So you could interpret this as an argument from analogy or a generalization. And then the conclusion follows with probability that none of our decisions are free. So we've got that deductive argument that particular decision is not free, and an inductive argument that probably you don't have free will at all.
I can see that this is a valid argument. The question is it sound? Are these premises true? But how might somebody that's like, no, I've got free will, how might they respond?
Yeah. Well, you say that. I kind of want to step back and say, well, we don't want to already assume our conclusion before we analyze the argument. We want to see, well, is this a good argument, and just let the truth guide us. Does that make sense?
Yeah.
All right. Well, Let's just take it from premise one.
Okay.
Why should we think that unconscious decisions are unfree? So that's one question we might ask. And we might, so I've heard other philosophers, none of this is unique to me. All of the stuff that I'm presenting here is stuff that other philosophers have already pointed out, and I'm just kind of summarizing what everybody else has said. So one thing that I've heard people say, philosophers, is that there are kinds of actions that we perform that become automatic because we do them so many times, and maybe we practice them. So think about elite athletes who practice over and over again. Like, what would you do in this situation? What would you do in this situation? And they've got so much repetition and so much practice that they've trained their body to react in certain ways to certain situations. Like, you imagine a world-class tennis player who reacts to the tennis serve that's coming in at 100 miles an hour before they even consciously are aware of what their body's doing. Or the baseball player who does the same thing when they're batting, when somebody's throwing a 100-mile-an-hour fastball. Or the football player who is trying to read the defense and figure out who to throw the ball to, and they might notice something just out of the corner of their eye, and they've studied defenses so much that they just react and they do it without even thinking about it. Do we want to say that all of those kinds of actions are unfree? And that to me, that seems like a stretch, because you think of all the process that led up to that point of being able to do it automatic. That's part of what makes an elite athlete an elite athlete, is they don't have to stop and think about it. Whereas if I was trying to be a quarterback, I'm sitting there like thinking about where I'm going to go with the ball, and then I get sacked and broken in half because I'm not in good shape. So that's at least one reason why we might not think that all unconscious decisions are unfree decisions. Another kind of action we can think of as an action where consciousness is, I'll call it front loaded. So what I mean by this is that all the deliberation comes prior to the actual decision itself. Just think about the way that we make big decisions, like what college to go to, or whether or not to have kids, or when to have kids, or whether to accept a job offer in another part of the country or in another part of the world. Like, these kinds of decisions we don't take lightly, and so we deliberate over a long period of time. And it might take days or weeks even, and then one day you just wake up and the decision is made, and you're like, oh, okay, I guess I'm going to take that job offer. Well, we don't want to say that decision is unfree, and it involved consciousness, but it didn't necessarily involve consciousness at the moment of decision. It was all, that's what I call front loaded in the past. So this is another reason to doubt premise one, because that decision itself, if it was unconsciously made at the moment, it involved consciousness in a way that it seems like it's a free decision. So that's some reasons to doubt premise one.
Okay.
Now let's talk about premise two. So we might wonder what exactly is going on in the unconscious brain activity. I don't think it's clear that this is evidence that the brain is actually causing a decision before participants are aware of their decision. And here's one reason to be doubtful of this premise. In the instructions for Libet's original experiment, subjects were instructed to recall the location of that on the clock at the time of their initial, and then there's this disjunction, their initial intention or wanting or decision or urge or wish to move. So it's different terms are listed in different places if you go and read the original study. So then you ask, well, was it a decision, or was it an urge, or was it a wish, or was it an intention? So in order for this argument to work, the brain has to cause your decision before you're aware of it. But it might just be an urge to move. And just because you have an urge to move doesn't mean that you're actually going to move after. Hopefully, most of us have impulse control enough to not act on all of our urges.
Yeah.
The world would be a much worse place if we didn't have that. So it could be that the readiness potential is just spotting like an urge or some kind of a desire that happens before a decision. So that's one reason to doubt. And there's other experiments that have been performed that give us further reason to doubt. So I'm going to set up another kind of experiment that's happened. in this other experiment, subjects were told to press one of two buttons. So instead of just flexing a wrist, they got two buttons, and they either push the one on the right or the one on the left. Except, and the difference in this one, they didn't wait for the urge. They were told not to make a decision until the sound of a beep or some signal, a go signal. And then the EEGs were reading the readiness potential again. So in the study, some people touched the right button, some people touched the left button. And what they found was the people who were told not to make the decision until after the beep had no difference in EEG readings between the people who press one button rather than the other. The average time between the decision, so remember they have to make the decision to press the button at the beep. The average time between the decision and the muscle burst that they were recording to press the button was only 150 milliseconds. So if we go back, notice the rise of RP happens at 550 milliseconds. The conscious awareness of intention happens at 200 milliseconds. And so these people in this study are reporting, or they didn't report, they made the decision to move. And then the other machine that measured the muscle activity recorded muscle activity, and it was a 150 millisecond gap. So it's like reaction time. And scientists have been studying reaction time for a long time. So it seems like this kind of experiment shows us that the conscious decision to do something can be way closer to the action than what Libet originally thought.
Okay. So those are a couple of reasons to doubt premise 2. Those seem like the two key premises, right? Because once you've established that's like this decision isn't free, I guess maybe you could call into question the generalization, but
yeah, well,
does anyone do that?
We can
Does
get
anybody
there.
question
Yeah.
4?
I think this argument has problems every step of the way. We haven't even really talked about the methodology. So these kinds of experiments are based on averages. And that seems to pose a problem because we're trying to say that, you don't have free will based on experiments that are done with averages. And the way averages work, they probably fall in some kind of bell curve. So that means there's going to be people on either end of the bell curve that didn't have the readiness potential like we saw in the graph. So that's another reason to doubt. I think a worse problem, or a further problem, one that is worse with the methodology, is that the readiness potential is backtracked from the wrist flex. So what that means is the EEG system is complicated, and it has to have a signal to record the data. Otherwise, it doesn't know when to record data and when not to record data. And the way they set up Libet's experiment was the wrist flex itself is the signal for the computer to collect the data of the readiness potential. So this is what I mean by backtrack. So now imagine what's going on. The computer is only collecting data when the subject actually flexed their wrist. There might have been other cases where the subject forgot or got sidetracked and daydreamed or decided not to flex, and there's no data from those kinds of cases. So like the experimental design, you have to have a control group and an experimental group.
Right.
So all we have here is the group that flexed their wrist. We don't have a group that didn't flex their wrist. So
okay.
we would want to see the graph of the readiness potential of the people that didn't flex their wrist and compare, because it might be that there's readiness potential in both. And then that calls into question that this readiness potential is actually causing the decision. So that's some problems with methodology. Now, let's grant the neuroscientist who wants to say that there's no free will the benefit of the doubt and say that the conscious or the readiness potential actually comes before a conscious decision, and just grant them that. Well, again, that doesn't mean that consciousness plays no role in decisions. And I already gave one kind of example of when somebody deliberates about a big decision, and there's lots of conscious processing taking place beforehand. So another reason to doubt. So far, we've talked about 1 through 3. And you already mentioned the inductive generalization. We can call into doubt that too. And this might even be a bigger problem because the generalization requires us to say that all of our decisions are just like the decisions in the experiment. But remember what kind of actions are being done in the experiment. They're all wrist flex kinds of actions or button presses, really simple bodily movements. And in all of them, the people are told what to do beforehand. So they're told, you're going to flex your wrist. You just get to decide when to do it. Or you're going to press a button. You just decide which button to press. So do we want to say that all of our actions, especially the ones that are most characteristically the ones that we think of with free will, are like button presses and wrist flexes? Or do we want to say, no, there's something special about these other kinds of decisions? Maybe those kinds of decisions are caused by the brain before you do them. But what about all these other big ones that we've talked about before, like where you're going to go to college or which job offer you're going to take and all those? We don't have as much data about those big deliberative decisions that take time. Because imagine what kind of scientific experiment would be able to do that. They'd have to have somebody hooked up to an EEG or fMRI for like a month when they're deliberating about whether to go to college A or college B. And that's very impractical. So that's a big reason to deny this generalization that all of our actions are just like the ones that they're studying in these experiments. And we've actually got some good scientific evidence that there are different kinds of decisions. So researchers have made a distinction between what they call picking and choosing. And when you pick, you're making a decision where there is no reason to choose one rather than the other. So imagine going to the grocery store to buy a gallon of milk, and you look at the cooler, the refrigerator, and there's 14 identical gallons. You've looked at all the dates, so they all expire on the same day. There's no reason to choose one rather than the other. You just pick one. Choosing, on the other hand, is deciding based on reasons, differences between the two. So this might be where you're deciding to buy the organic milk or the conventional milk or whole milk or skim milk. There's actual reasons to choose one rather than the other in that case. And so all of these kinds of experiments that we've talked about so far only involve picking. And this is a kind of decision. And some neuroscientists have actually mapped out parts of the brain that are more involved in picking decisions. And then there's other parts of the brain that are more involved in choosing decisions, or the choosing kind of decision, where we're actually deciding between things that there is a reasoned difference between the things that we're choosing. Mm-hmm. So if we want to try to prove that there's no free will, we're going to have more experiments that involve more choosing. And some scientists have done these, and they haven't seen a significant difference in the EEG between people who are choosing between different things. And I'll mention one study in particular. The people doing the study were worried about the same kinds of things that we're just talking about. So instead of just having a button where there's no difference between the two buttons, they gave people a hypothetical amount of money. They say, all right, we're going to give you $100 and you get to donate it to the charity of your choice. And then they gave them a choice between two charities. You can either save the whales, or you can save the trees, or you can alleviate third world poverty, or donate some money to a local homeless shelter. So there's actual differences between the things that they're trying to choose between. And then they press buttons to decide where to send the money, one charity or the other. And this is the one where there wasn't a significant difference between the EEGs in the groups who chose one charity rather than another.
Did you have anything else you wanted to say before we start to wrap up?
No, I think we covered it all. I think whenever you hear people, because when you asked me to come on, I looked up on YouTube to see what kinds of videos there are where people are claiming that neuroscience has disproven free will. And in a lot of them, they talk about the Libet experiment. And I guess we should be aware that there's been a lot of scientific and philosophical research since the 80s.
If this interests you, you should go check out, which season is it? Is it season 2 or?
It's season 3.
Season 3.
And we actually interview some of these neuroscientists that are doing the experiments now. So we've got episodes with psychologists, neuroscientists, and philosophers of science. And they run the gamut of all different kinds of arguments concerning free will and science. So yeah, it's really interesting stuff.
All right, you heard it. Go check out season 3 of the Free Will Show, and while you're there, give them a good review on the podcast. It's a great show. I've listened to all of season 1 at this point, and it was excellent. I need to get back and listen to season 2. Can you summarize in to the best of your abilities, like in 60 seconds if possible, how you would respond to somebody who says, does neuroscience disprove free will?
I would say no. And the reason is because in all of the neuroscientific studies that study how actions are produced, they're always studying simple motions like a wrist flex or a button press. And like every single neuroscientific study is always about that kind of stuff that try to disprove that free will exists. And if that's going to be our evidence, then we don't have enough evidence to say that the big kinds of decisions that we make when we actually deliberate over time are not free, because they haven't done any studies about those big kinds of decisions that happen when we deliberate over time.
Thank you so much, Dr. Flummer, for coming on. I really enjoyed talking to you. This was a lot of fun.
Yeah, you're welcome. Thanks for having me on.